Hey guys, this is Manak and you are watching Civil Bro. Today we are going to show you how to import the coordinates of Staad to Safe for the foundation design. Safe is a software which you know is used for foundation design and is a product of CSI. It is used along with ETABS, but we can also import the Staad model to ETABS and design the foundation because, as you know, Safe is a very popular software for design of foundation. And if we suppose if we make a model in Staad, we're not comfortable with ETABS, then also we can work in Safe and design the foundation. Okay. In this video, we'll see a very simple procedure to do that. The procedure is very simple. Once you import the file into Safe for the foundation design, the entire process, the remaining process is the same. Let's proceed. Today we'll just design the isolated foundation in Safe by importing the coordinates from StatPro, importing coordinates and loads from StatPro. If you watch the video till now, drop a like and let's continue. Okay. So this is a model which has been designed in Staad. First of all, after analyzing, after designing it, what you need to do, we need to select the coordinates. So I'll go to the front view, I'll select the, this coordinates or the footings here. And after selecting the coordinates of the footings, I'll go to the post-processing mode. And in the post-processing mode, it will have the reports and the reports we have your uh, this reactions. But before that we need to just find out the coordinates. For the coordinates we can go to your modeling and you're in geometry. So in geometry, if we just move up this, we have the coordinates of these points. So first of all, we copy the coordinates here and we'll open an Excel file, and in this sheet we'll just copy the coordinates. Now we know that first of all, I'll just make it center. So if you write here, what are the things which are in this stat? So it is this node and sorry, it is node, and then it is the coordinates is x, y, and z. So x, y, and z. So we know that's safe and AutoCAD what x and y, in this z are interchanged. So we'll select this and just move it here, and we'll select this and move it here, and select this and move it here. So what I did is just interchange x and z for the input. Okay, because in ETABS as well as in AutoCAD, the x, the y and z are interchanged. Okay, so now the coordinate is correct for importing ETABS. Now the coordinate is done. Now next we go for the loads. So just open a sheet, this sheet 2. In the sheet 2, we'll just go for the loads. So first of all, we'll go to the post-processing mode, and already the coordinate nodes are selected. If they are, by chance it became unselected, just select them again and again, then go to report, and then we have this support reactions, and go to loading, and just select all the loading here. Now in ETABS only there is the option of load combination. Sorry, not in ETABS, Safe. So you don't need to have any load combinations imported. Just select the basic load cases which you have done, and then just click on OK. You can see everything is being displayed here. Just select the above cell and Ctrl+C, which is copy, and then you just paste it. So once you paste it again, we need to do the same thing. That is, we need to exchange the y and z. So I'm just taking the y here. When this option appears, I'm just taking it here, and this z option, I'm just putting it here, and this one I am just bringing it back here. So similarly, I'll do the moment also. Moment in this moment, I'll just place it here, and the Z moment, I'll just place it here, and this one also, I'll place it here. Okay, so then the loads is ready for now, but we need to make more changes. Whatever the changes are, I'll just let you know in some time. Okay, so then we'll open the Safe. So this is how the Safe looks like. So file, new model. And then first of all, you need to just change the code, because we are designing in Indian code IS 456, or you can select the code which you are designing. In design preferences, you can change the this minimum cover of slabs here. 75 is for the footings. As we know, this footing is designed as a slab, so that's why it is 8. So there is no problem in that. We'll just click on OK here. uh, Project info, if you want to insert, you can do it. And units, always make sure you work in metric units, because we are using metric units in Staad as well. meter, mm, kilonewton, meter square. So all are in metric units. Okay, just click on OK, and you can open a blank file. So once you open a blank file, so very easily, first of all, you need to import the coordinates. So importing the coordinates, you'll go to edit and go to interactive database, and just select this option, expose all input tables and geometric data, and then the point coordinates, and just select on this table and then click on OK. So here you need to insert the coordinates here. You can see X, Y, and Z and special point. So here in the special point, we can write here yes. And after the clicking on selecting yes, I can just copy this to all of the points and the nodes. I'll just select yes, sorry, copy this from this Excel file and then paste it here. So so as you can see, just paste it here. So no problem in that. And once you just paste it here and then click on apply to model and then click on done. So the data will be imported, but it is not visible here. So we'll go to this the static item set display options, and then here just click on this levels and make the points visible. Okay, and then click on OK. So you can see the points here. Which has been imported. Now, once the points have been imported, next thing you need to do is you need to define some things. Okay, so first of all, define materials. And in the define materials, the first material you see, just click on modify. You can see this is a different material here. Just click on the second one and modify and show material. And you can see this is rebar. Okay, so rebar, just click on just will do FE550. The point, the date in which I'm making the video, the most commonly used rebar is FE550. Earlier it was 500, and very much earlier it was 415 in India. So 600 is also available whenever you are making the video, just design as per the available reinforcement, you add the rebar data, no problem in that. Okay. So FE 550, the strength is obviously more than 550 here, but I'll just do 550 here, and you can check from the internet and put the exact value, but it is more than 550. Okay. So I'll do 550 and then click on OK. And then I'll just click on OK here. Okay, my steel has been defined. Okay, I haven't defined the concrete. Okay, so FE550 has been defined. CSI, this one I'll just modify this one. This one, as you can see, this one is the concrete, property. So I'll just do M25. Generally, in footing, M25 is used. M20 also is used, but it's better that since it is a unfavorable condition, use M25 concrete. Little bit more better. Okay, so I'll just do this 25. No need to change anything, and then just click on OK. So now we have the M25 and FE550, and then click on OK. So we define the materials, and we now define the slab property. Slab is same as your footing. So we'll just modify this property here, and M25 grade has been used, and now this is slab, and minimum thickness will start from 300 mm. Okay, 300 mm minimum thickness will use. Generally it is used 250, 300 is used. So we'll just click on OK, and then click on OK. So this slab properties has been defined, and the footing properties has been defined. And then next thing which you need to define is your main important thing, which is soil subgrade properties. So we'll just quickly do the modify property. Now soil one and nothing need to be changed. Only the subgrade modulus need to be changed. So what is subgrade modulus? You need to understand here very properly. So subgrade modulus, I'll just type here subgrade modulus. Modulus is equals to the zoom in or better view. Subgrade modulus is equals to your SBC, the soil bearing capacity, divided by maximum permissible settlement. So maximum permissible settlement will both the units will just do it in meter. I'll just equal to, okay, now it will be better. Just wrap text this. So right now this one I'll just Control X and paste it here. Subgrade only modulus is SBC divided by maximum permissible settlement. So you need to have the soil test report to find out the SBC. So suppose the SBC is 150 kilonewton in this case, and maximum permissible settlement is 25 mm, which means equals to 0.025. Okay. So then the this subgrade modulus will be 6 into 10 to the power 3. Okay. So, and I'll give another example. Suppose the FGC is 250 and the maximum permissible settlement is 25 mm again and 0.25. And if you just do this, value, if you just calculate this value 250 divided by 0.025, so it will be 10,000. So this is the subgrade modulus in kilonewton. Okay. So now we'll do this subgrade modulus in kilonewton per meter cube as your this as 6 into 10 to the power 3. Okay. 2 into 10 to the power 4 was there. We'll do 6 into 10 to the power 3. So it will be 6e 3. Okay, so this is the case here, and then we'll just do it. Okay, so soil property has been defined. Now, once the soil property has been defined, then just click on OK, and now you need to just put the footing points. So all the footing points you need to put. So suppose I'll use a footing size of 1.5 meter in these two cases, because you can see the columns are a distance apart. So what I'll do, I'll just select this two coordinates here, and then we'll go to edit and we'll go to replicate, and then we know that this is the x direction, right? From your screen left to screen right is the x direction. As you can see, the x is made here also, and from bottom to top is the y direction. So here, if I made a footing of 3 meter, we'll just half of it will be 1.5 meters. So 1.5, and then again here also 1.5, and then just click on OK, and then you can see the coordinate has been replicated. And now we'll select these two, and we'll replicate in the x direction. So it will be minus x, so it will be minus 3. Okay. So edit and replicate. So in the y direction, no change required. In the x direction, we'll do minus 3 to replicate the points. We'll click on OK, then these points have been replicated. Then we'll select these points here, and then we'll go to edit and then replicate. And this time in the x direction, we don't want any changes. In the y direction, we are going to the bottom, from top to bottom. So it will be minus 3. So click on OK. And similarly, select this also, and then edit and replicate, and then minus 3, click on OK. So this has been done, minus 3. And after that, you can just replicate the other footings as well. So this two footings, I'll do 2.6 meter. So half of 2.6 is 1.3. So select this, go to edit and go to replicate, and then just do here 1.3, and here also 1.3, and then click on OK. So once this has been done, just select this 2 points and then go to edit and again replicate. Now we need to go 2.6. Now no need to change in the y direction, and in the x direction there will be 2.6 from your screen right to screen left. So that means in the negative x direction, that is minus 2.6, and then click on OK. So this has been done, and after that, just select this point and go to edit, then you go to replicate, and then no need to change in the x direction. We're going from your screen top to screen bottom, that is in the negative y direction, that is minus 2.6 again, and then click on OK. And similarly here also the same thing, just click on edit, replicate, and then minus 2.6 already there, OK. And in this point, we'll go with your 1 meter footing. So here, just select this point, and then we'll go to edit, go to replicate, and we'll go 2 meter footing. So half of it will be 1 meter. So 1 and comma 1 increment, and then click on OK. And here, just to select this and go to your edit, go to replicate. We are going to give the left point of the footing. So no need to change in the y direction, just in the this x direction, minus 1, and click on OK. Okay, so sorry. This will be minus 2 because it will be the entire size of the footing. So it will be minus 2, and then click on OK. So after that, just select these 2 points, go to edit, go to replicate, and then In the X direction, it's keeps it as 0. No need to change. In the Y direction, from your screen top to screen bottom, it will -2, and then click on OK, and this has been done. And then quickly you can go to your uh, draw. So in the draw option, we'll just use here draw rectangular slab areas. If the footing is irregular, you can select other options, but slab 1 already we have defined slab 1 everything. So what you need to do, just select this point and don't leave your mouse, and then go to this point and then leave your mouse. Like this, we'll just do for all the footings here. So we are defining the slabs, that is footing is designed as slabs. So that is we are defining all the slab points. Okay. So then we just click on this and close it. So now, as you can see, go to display here, and you can see labels. It's turned on OK, and this is done. And then you can import the loads here. Okay. So to first of all, to import the load, you can go to define, and you can see the load cases. Okay, load cases, you can see load cases which are there. Two load cases are there. You will go to define and go to load patterns first. Two load patterns are there, date, live. Okay. We are applying seismic load as well in the stat pro. If you see in the stat pro, you can just go to the load. What are the loads which are there? You go to modeling. This can be a little different depending on how you apply the loads. You'll go to your after going to general, we'll go to loads and definitions. So you can see how I have applied the loads. Seismic load, first to a seismic load in X and Z, and then the dead load and the live load. So seismic load I need to add. If you applied wind load, then you need to add wind load there. Okay. So here I need to add a new load pattern. So this will be nothing else than seismic, SEISMIC. Okay, I'll just do everything in caps. Okay, seismic, and in the X. Okay, so this will be earthquake. Shortcut is there, quick, and add another load pattern, seismic, and Y. This again will be quick. Self-weight multiplier not required, only in dead load is there, so which is already there. No need to change a thing. Seismic Y, and then click on OK. So now in this, we'll go to this sheet, and in this particular sheet, we know that we need to change some things. So this need to change here, and first of all, this load is SEISMIC seismic X. Okay, and then the next load, I'll just copy this. This load is the seismic Y. Okay. Okay, sorry, in this particular, I'll just go to define and load patterns. Seismic was X and Y, because in this ETABS it is seismic X and Y. In StatPro it was Z, X and Z, or X and Z. But in this ETABS it is X and Y. Okay. So then we have dead. Then we have live. So in ETABS also you can see the spellings of the load here. Go to define, go to load patterns, and you can see the spelling in capitals. Dead and live is there, so no problem will be there. Okay, so go to the Excel here, dead and live is there. So then you can just select this, copy, and then paste, and then paste. And then here also, just the coordinates, you can just copy this again, and again, and again. And then you have another option for the column sizes, and column sizes option is 300 and 300 in our stat pro. So whatever the column sizes are there, you can just copy. I'll just copy it all. Okay, so this part is done. Once this part is done, I'll just what I'll do, I'll just go to this, I'll just click on OK here, and after that I can import the loads. So for importing the loads, so what I need to do, I just need to go to your edit, interactive database modeling, expose all tables, click on OK. Sorry, the wrong point. Go to edit, interactive database modeling, and then just expose all tables, assignments, and then you go to your load assignments, and load assignments, you'll go to then your point loads, and click on OK. you have this here. The best way to import, as per my experience, is from Excel. Send database to Excel. Takes some time, but there's less probability of any errors. Excel file will open here, and in here, what you can do is we can just copy these loads, Control plus C, and then in this Control plus P, the Excel file which has been sent by this. Just final check, everything is okay or not, interchange positions and all. So this is done here, and after that just save it. Okay, Control plus S. I'll just save it in document here. Okay, document book. Let it be just book 2. Okay, and then save it. And after this, just go back to your ETABS and Excel and retrieve the database from Excel. Automatically to retrieve, apply to model, and then click on done. If there is an error, it will come, but right till now there is no error which has been displayed. So if you just click on show loads here, and show loading values, if you just click as well, if the loading values will show, or point loads, just you can see in the 3D the show loads are there. You could see the values also. Just click on this loading value, the values will also be displayed. Okay, so like this you can we have imported the loads. Okay, different loads, and this will be displayed here like this. Okay, so here it is there, and you do it like this, and I'll just go to the back to the 2D view, and if the 2D view, just click on this XY, we'll go back to the 2D view, and here I can just do right now. What we'll do, I'll just to avoid confusion, we'll just get rid of the labels here, and labels here, just get rid of them, and then we'll go to assign, and you can have various things here right now. So you can first of all draw your design strips. Okay, so draw design strips. Just click on this, and we have two strips here. So we have column strip A and column strip B. So column strip A, let's take along the perpendicular direction, and B, let's take along the vertical direction. So the size of this footing is 3 meters, so it is 1.5 meters. So just select this midpoint, and this midpoint, and then right click, left click, right click, and then you have this A thing. So this is your 2 meters. So it will be 1 meter again for all. 1, 1, 1, 1. Left click, and right click, and then it is 2.6 meters. So half of 2.6 meter will be 1.3 meter. 1.3, 1.3, 1.3, and then again 1.3. Once it's done, just go to this and right click, and then select this and right click, and then we'll go to column strip B, and first of all let's finish the 1.3 here. Okay, right click, and then right click. So then we'll go here 1, 1, 1, 1. So left click, and then right click, and then the last but not the least, here 1.5 for the remaining two footings. 1.5 here, 1.5 here also, 1.5, and then again midpoint, right click, midpoint, right click, and then close. So this has been, the column strips has been defined now. Okay, so first you can save the model here, and save, let me just save it as save to, and then click on enter. So the model is now saved. So now what we can do, just click on escape after this strip has been designed. Just click on escape, and then click on escape 2 times, and then when you just select all the properties, then you just click on assign. After that you can go to support data, and then we'll assign the soil properties. Soil 1 already there, and then click on okay. Soil 1 already you've defined everything. So this has been defined. So once this has been defined, and you can go to this option, run analysis and design. So the model will be designed here. As you can see, these are the various degrees here. So, and after that, you can just select this option of show strip forces, dead load, live load. So let's select any dead load combination here, and then see the your moment, apply. So you can see the moment here. Moments here you can easily see, and you can see the layer B as well. Now apply. So you can see the other layer of this moments, layer A and layer B. So this you can easily see. You can also see the torsion, and click on apply, and the axial force, click on apply. So like this you can just see all the forces here. So this is the case, and for the design, let me show you. Just you can show slab design, right? And for the design, what you need to do, just select this typical reinforcement, just impose minimum reinforcing. Okay, we'll select 10 mm bars, 10 mm bars. Let's select the spacing of 150, and then go again 150, right? Click on apply, and you can see at the top and bottom there is no problem in that. Slab reinforcement layer A. Just click on the layer B as well. Just turn on the layer A and click on layer B and click on apply. And you can see there is no problem in layer A or layer B for this. And suppose if you do this as 250, okay, 250, and then you click on apply, and then you can see there are error. So it is not safe. So again, we'll go back to, let's say, 175 and 175 because we want the most economical, and then click on apply. And then you can see there is error in one particular footing here in layer B, and in layer 1, apply. Layer 1, there is no problem. So we'll go with your 150 and 150, and then click on apply. So in layer A and also in layer B, there is no problem. So this is our footing design. The sizes you already know. Thickness is 300 mm, and the bars design we found here. So like this, we can design the isolated footing in ETABS by importing the data from StatPro. So hope this video helps a lot, and make sure you comment below if you have any doubt. Okay, keep learning. Bye bye.